Hello, everyone, and welcome to another K6 Office Hours. We are back from our break last week. I am Nicole van der Hoeven.
And I'm Paul Baylog.
And I'm Benjamin Wilms.
And today we have a very special guest, Benjamin Wilms, who is the co-founder of SteadyBit. Benjamin, welcome to the show.
Hello again, and sorry for interrupting you.
No, that's fine. Latency, I'm sure that'll happen a few more times, inadvertently.
Yeah, absolutely.
So tell us about yourself. What is your background in, and how is it that you come to be on K6 Office Hours?
Yes. So how to start? So first of all, I'm a developer. I started as a developer 20 years ago, 1999, and something which was always like pushing me or getting me a big motivation is to solve a problem and to be able to share the solution and how I have solved a specific problem and to get feedback or to help other people. And that was something where I was able also to get into the topic of chaos engineering because I joined a project at my former employer where we were very close to production, the first release into production. And there was a very good test coverage. There was a very good load testing suite prepared. But I'm a little paranoid. So I was asking is everything working also under bad conditions? No, we never checked it. And that was, my starting point with chaos engineering.
Yeah, so let's talk about that a bit, because I know when I was tweeting out the link for this session, you said something about how you're looking forward to talking about unhappy load testing. What is that?
Yeah, normally, to be honest, if you have developed something new and you would like to get it out into production, you will not inject normally bad behavior because no one would like to hit his own baby, so that's I call it happy path testing. So and you need to inject bad behavior. You need to understand and learn how your applications are working under real conditions. And to be honest, production is not a nice place to be as an application. So that's why I call it unhappy path.
That's funny. Yeah, never quite heard it put that way.
It's a special way. Yeah.
But, it's, I guess, because there are always tears in production. So.
Yeah, it's also kind of the Ikea effect. I feel if you've built something, then you tend to be a little bit more emotionally invested and maybe in your head have over-exaggerated how reliable it is or how stable. And maybe you might not be as interested in, throwing a bunch of chaos at it to see what sticks and what doesn't.
Yeah, because no one's really going to do that. No one's going to misuse your application intentionally.
Yeah, and users are using your application in a way you never have expected. Or if you have created a new feature and you have developed it, maybe there was a tiny misunderstanding in your implementation. And then you're also writing the test cases with the same misunderstanding. Are you able to get this insight? Are you able to see if something is really working?
All right. So can you tell us about SteadyBit?
Yeah.
And how did you come to co-found it?
By accident.
Like all good things.
Really. So I started with the topic chaos engineering 6 to 7 years ago. And I started with open source tools, and I was able to do it at customers to get started as fast as possible. But something I've learned was, you need so many different tools to do chaos engineering or to check and verify if your system is still working under bad conditions, that you need to be an expert for all these tiny tools, and you need to get them in your pipeline. You need to get special permissions to maybe kill a pod, to inject latency on the network layer. And so I was not longer focused on doing experiments, doing testing. I was focused to get the right tool in place. And that was the starting point where I created an open source project called the Chaos Monkey for Spring Boot. and this was being picked up by many people around the world, like people from very big enterprise companies, from very small startups, and they have all the same problem to solve like me. And that was like, wow, there's something more to do. And so I was able to get more time from my former employer, and I was also to be able to share my knowledge, my experience with other people from the community. And then, by accident, there was a very special meeting with one of the founders from Instana, Mirko Novakovic, and he told me, Benjamin, maybe you should start your own company. I can help you. That was, wow, okay, yeah, and that's nearly 3 years ago from now, and we founded SteadyBit in total with 3 founders, my ex-colleagues and friends from Codecentric, Dennis and Johannes, and since today we are 11 people, and it's like a roller coaster. Yeah, it's going up and down. A startup, yeah.
That's awesome. So what is it that SteadyBit does?
We started with just chaos engineering, but with the help of our customers, with our friends from the network, we learned quite fast, okay, chaos engineering is more like an engine, something you are using, but you need to focus on a more testing approach. So that's also the big difference to open source project. If you compare SteadyBit to other open source software or other competitors, normally people are just getting started with an attack. So it's like they are picking up a hammer from the toolbox, using the hammer to hit their own system, and they are just verifying if the hammer is working. But they are not learning, they are not creating value, they are not testing for specific behavior or capabilities of the system. And that's the core difference which SteadyBit is doing. So you can describe your expectations, you can describe your capabilities of the system in a very easy way, and you can do chaos testing or resilience testing, because that's feels more natural for a developer. It's like given when then, and I would like to see some test cases needs to be green, and then I'm a happy guy. Otherwise, I need to improve.
Yeah. So I'd like to share my screen a bit just to show the SteadyBit homepage. I think it's really interesting, like you're talking about resilience testing and not particularly chaos engineering. Is that word choice or phrase choice intentional?
We would like to how to frame it right. So chaos is a smaller part of it. You need to improve the whole stack. You need to improve your organization, your departments, your people that are involved, and that's more like resilience. It's like you need to be prepared for this continuously changing situations in production, and it's not only a job for one person. It's a job for your organization, for your teams. It's like the SRE department sitting in front of production. They are more hunted by production. There are so many incidents coming up. They need to find a way how they can share all these findings, these issues, these events with their development teams, with their product teams, and that's more, and it's more like resilience engineering and not only just chaos, because chaos is already there in the system.
Yeah, it makes me think of how we have the whole, load testing versus reliability testing, the umbrella term.
Yeah, exactly.
Yeah, that's actually what I was thinking as well. Maybe resilience is the like the parent one, because we always think, is performance part of reliability or is reliability part of performance?
Mm-hmm.
Does functional testing fit within resilience, do you think, Benjamin?
Yes, of course. It's the overall goal, resilience, and there are some categories or some steps you have to achieve, like reliability, like load testing, like performance testing. That's everything is fitting into this bigger goal, like resilience in the organization, in the applications.
Okay, so it seems like SteadyBit is a SaaS platform, but it is also there is an on-premise solution for SteadyBit as well. Is that right?
That's correct, because your killing parts of your system. You're injecting latency in your system. Maybe you're not allowed because of some restrictions. Maybe there are some rules or some policies in your organization, and you should do it also. And that's why we have picked up, like, you can use our SaaS offering, or you can use our on-prem version. It's absolutely on the same level from the feature set. And also some customers are doing it like, okay, here's our cloud provider, AWS, and they are running the platform and the agents in their AWS account. So it's still an on-prem version, but they can use it as they would like, as they can use our SaaS offering. There's no difference.
Okay. And I know that the reason that you came up on my radar, at least, is that you happen to have an awesome integration with K6. That's really awesome, because I think that load and chaos or resilience go together really well, but very few offer both.
Mm-hmm. And why we have picked up load testing and why we have picked up K6 is normally, if you take a look at the principles of chaos engineering or the methods, you should do chaos engineering in production. But in my opinion, it's too late if you're just doing it in production. You need to do it in an early stage. You need to do it in your dev cycle. And what's the biggest problem in a dev or test stage? There's no traffic. So that's why you need to have a load test. This load test can be executed, and also during the execution of the load test, you can inject bad behavior with the help of SteadyBit. So that's like you can improve your system before you're in production.
That's, definitely shift left. That's what it's all about. I mean, it costs less if you find and, discover and address these issues early.
Exactly. And the trick is you need to transport this knowledge from this expert group for like SRE departments, DevOps people who are taking care about production. You need to use this experience to hand over to your dev teams, that they can maybe replay an incident, or maybe they can use like the post-mortem analyze done by the SRE departments to improve their own skills during the development, and also to improve their next features or the next release of the application.
Cool. So can we jump into the demo, and you can maybe show us a little bit about how SteadyBit works?
Yes, of course. I'm ready.
All right.
Yes. Okay, let me add it.
Okay.
What are we looking at?
Maybe let me start with some slides. I'm not
okay.
Just some. So
no problem.
We have created SteadyBit as a kind of orchestration platform where you can integrate your existing stack. That's a very important topic for us, because no one would like to build the next monitoring solution or maybe use the next tool. It's like you need to integrate with existing tools like K6. And that's why we have built integrations into monitoring solutions to take care about events that are triggered during experiment executions, or like Docker, Kubernetes. So that's what SteadyBit is taking care. And how we are doing it? We are doing it with an agent-based approach. So you need to install agents in your system, and the agent's job is to discover your system, because your system is continuously changing. New instances are coming up. Maybe some pods are rescheduled. Maybe there's an auto-scale event or a load balancing event. And this needs to be recognized by SteadyBit, because you would like to reuse existing tests like a regression test. You would like to repeat it over and over again to see if this behavior is still handled by your system or not. And that's why you have to install agents with SteadyBit. And that's all about the slides I would like to share, nothing more. So,
just curious on the, if I could ask real quick on the agents. So, I mean, every time I hear about some of that stuff, and like with this kind of, I guess, the space that we're in with this chaos testing, it always makes me think of the service mesh, you know, where like Istio or Linkerd or things like that. I'm kind of curious, the agents, are they based possibly on Envoy proxy or anything like that? Because I know you can do a lot of this with Istio, or I believe you can.
Exactly. So if you have like a service mesh like Istio, there are ways how you can do it. Or also maybe you are using an API gateway like Kong. There are also ways how to reconfigure existing routes or rules that can be applied. That's a way, of course. But there are multiple levels of how you can inject behavior. You can do it, of course, on the infrastructure level. You can do it on the platform level, like Kubernetes, like your cloud provider, or you can do it on application level. And it really depends on your entry, on which level you would like to get started. And there are, let's assume you would like to see, I would like to simulate a zone outage in my cloud provider. So I can do it on different ways. I can do it on an API level with AWS to do a network SEL attack to reconfigure your AWS account that one zone is not reachable for you, for your applications. Or you can do it on a smaller level. So for example, I would like to simulate a zone outage for just a small group of containers or pods and not everyone who is inside of this zone. So it's like the blast radius. So far, so good?
Yep.
Okay.
Yeah, that's good.
Okay, so SteadyBit is installed, the agents are running, just 2 agents are running in this demo showcase, and they are collecting a lot of data about all the potential targets in your system. And that's quite important for you because you need to use this data to create experiments, to describe your test and create a target group which you would like to test. And you can see we are able to discover on many different levels, like mentioned on container level, or we can discover your host you are running. We are able to discover Java-based applications, or there are some cloud components like EC2 instances, or maybe someone is using the failure injection service by AWS. And all those components can be discovered by SteadyBit. And EC2 instances are a special type because you are not only just installing an agent on a virtual machine or inside of Kubernetes as a daemon set with SteadyBit. You can also install a special kind of agent. It's called a cloud provider, AWS agent. And then you are just installing it once with some special restrictions, of course, into your AWS account. And we can do many things on the API level. So that's what I mentioned earlier, like on which level you would like to inject the bad behavior. And of course, we are able to discover Kubernetes deployments, namespaces, the Kubernetes cluster you are running, and so on. Okay, so first experiment.
Let's do it.
Let's do it. Let's create an experiment. So there are multiple ways of how you can do it. Of course, there is a guided way, but I assume we are the expert now. So let's get started. Let's get started. So on the left side, you can see I have just created a very simple K6 load script. And there are 2 ways of how you can interact with load tests when you are using SteadyBit. The first one I will show right now is SteadyBit can reuse your existing load tests. And that's something quite important for us because we would like to enable developers to get started in their daily workflow and with their existing tools. And there is normally a load test you are using to develop your new application. And that's something we would like to reuse because you don't have to recreate everything. So that's the one way. So just drag and drop. And now we need to share some internals like the virtual users. It's just easy at that. And the target URL. And I'm using a very tiny demo. It's like a nice online shop where you can select some products. There are 3 backend services providing a list of products like hot deals, fashion, and toys. And I will check if this endpoint is still consumable or not. So I will create the load to this specific URL with K6. And that's all I have to do. Now, it's just a load, but we would like to check for what's going on if the system is not working as expected. So let's edit a black hole attack. You can see there are many different type of attacks you can now select to just drag and drop and to use it in your experiment. And now I'm just describing the group of targets I would like to use during the execution. So I would like to attack all targets from one specific Kubernetes deployment, like the hot deal service. But also, I would like to combine some more attributes. So I know this Kubernetes cluster is managed by AWS. So maybe there was a zone outage. And I would like to attack all specific containers in one or two specific zones. And that's how you can reuse all this discovered metadata, all the moving parts, which SteadyBit is able to see. Still boring. We need to do more. So I would like to add a simple wait step up front. And as mentioned, K6 is at this point just creating load. So we need to check the system under test if it's still responding or not, because I would like to see a specific behavior. I would like to verify that my system is working even under bad conditions. So you can do it with an HTTP status check. And we're just using the same URL, this product's endpoint, for 40 seconds in total. So far, so good?
Yeah.
Perfect. Okay, I'm famous for naming. So AWS, sound outage. Very creative. And now we can execute this experiment. Now, SteadyBit is taking care about the execution of the K6 load file with one of our agents running in your organization, in your application, in your environment. And also, SteadyBit is now executing the attack, the black hole attack. So the containers are not reachable. Black hole is like the containers, there are no incoming or outgoing connections possible for a specific time window. And as you maybe have recognized, that's not the way how you can create real load in your system. That's something we can see later on if Nicole is doing it from the outside, because you can also use an existing experiment to be triggered by an API call outside. And then K6 is been executing and calling SteadyBit. It's like the other way. So this test has failed, which is perfect. So I'm always happy if something is red in the world of resilience engineering, because then you have created value, you have created an insight, you can improve your system. And as you can see, okay, we are not able to provide service for our customers if one of our services called hot deals is not reachable. So a finding, something we need to fix. Our entry point, this shop is not reachable. Yeah, not so fun. And with this deep integration with K6, we are also able to get the action log. So we can see all the details provided by K6. And yeah, as mentioned, it's just a load test, but we can now improve. Let's do it in a different way. We can remove our check, HTTP check, and we can now use another tool, another script. And this time you can see there are some thresholds where K6 is taking care about, is it a good run or not? Is it how we would like to see our system, or is there something we need to improve? And let's remove the old one. Whoop. Enter the new one. And just rerun. Save. And rerun. So now not SteadyBit is checking if the system under test is in a steady state. It's the job of the K6 file, of the K6 load test. Any questions so far?
That's pretty cool. So not a question.
Not a question. Okay.
Wow, okay. This is really cool. I hadn't played with this part. It's kind of cool how you can visually see different tests and different attacks as well.
Exactly. So it's still running. service under test is, you can see some events coming in from Kubernetes. So SteadyBit has recognized, okay, your targets you are now using in this experiment are part of a Kubernetes cluster. That's why we are putting automatically events inside of your report. So it's like in this existing execution that you are later on able to see, okay, what was the issue last week we discovered with SteadyBit? Okay, here are all the details you can now use. So still running, and fingers crossed. We need to wait for the end of the K6 load file. Yeah, failed. And this is an exit code provided by the K6 execution because, scroll to the bottom. Here we go. Has failed because of the thresholds. And that's how you can combine it. That's how you can reuse your existing load test. And you don't need to do it over and over again for yourself. So, anything else you would like to see or to talk about?
So what were the all the different attacks, I guess, you had listed? I know, obviously black hole. What were some of the other ones?
Exactly. So there are categories like some resource attacks where you can simulate CPU overusage or memory footprint is getting bigger, and you can change the state of containers, like to pause it for a while or just to stop it. And most of the time you're using something from the network because normally something is not reachable or not responding in a specific time, and that's how you can replace specific outages from the past with some network attack, like block DNS traffic or delay traffic to a specific resource, package corruption to mark some packages on the network stack as corrupted. That's all possible. And the big advantage is you don't need to use specific Linux tools, or maybe you have optimized all your container images and you have removed all specific Linux packages, and SteadyBit is able to do it also with so optimized containers because we are providing everything you need, and we are doing it in a way that we're creating sidecar containers for the target under attack to inject delay on the network traffic or so. And
so I have a question. If somebody is not really sure how to start with these chaos attacks, because there's a lot that you can do with SteadyBit, are there ones that you would recommend as a good starting point?
Outside of SteadyBit world? Or with SteadyBit?
In SteadyBit, using SteadyBit.
Okay. Normally, you are not an expert, and the first question which normally came up from customers is like, where should I start, and what kind of attack should I use? And if you have installed SteadyBit, you can use our landscape because we are able to create a map of your system that you are able to see, okay, which service is connected to internal services and where's a good starting point, because of course, you can start in the back, like with toys or like we did with the hot deals service. So only this service has been attacked. If I start on a higher level, on the gateway, then the radius is getting bigger and bigger, and you will and more services are affected if the service is not reachable or not. And to provide you with some guidance or some recommendations, you can use a concept called policy inside of SteadyBit. And that's something where we would like to enable people to get started without any knowledge about chaos engineering or how should I start or where should I start. So you can start with, I would like to check my system, my specific service is if he is able to recover. Or maybe I would like to see if the system or the application gateway is able to handle more than one instance. And that's something you can just apply. And then SteadyBit is taking care about the check. You don't need to create an experiment. So that's something we can now see. So SteadyBit has already checked, like we have calculated a resilience score for you. your gateway application can handle the first two types of potential errors, potential misconfigurations. Like we have checked for a readiness probe. We have checked that you are not running a single replica. And also we created the first experiment for you. That was the question, like, how can I start fast? And we as SteadyBit are able to create experiments based on the data we have discovered. Oops, long press. And now that's the experiment we can just execute without to drag and drop or to take care about in which order should I select what. No, it's all done automatically.
We also had a question come in from one of our regulars, Naveen. He's asking about if you can mock these AWS, I guess that's elastic block storage, so like a file system attack. Are there particular handlers for that?
Very good question, and I'm prepared for that question.
Awesome.
Because, every system is a tiny snowflake, and we as SteadyBit are not able to create 1 million attacks or 1 million discovery components. And we would like to focus on the orchestration, on the hard parts, on security aspects, role-based access control system, all the boring part, and you can extend SteadyBit by your own. So there's a start free with SteadyBit version. You can play around with SteadyBit just right now. You just need to sign up and can use it. And then you can extend SteadyBit. You can extend SteadyBit to edit an EBS attack or EBS discovery. And that's already done by one of our customers and users. So they have created their own API Gateway Kong extension to interact with Kong. And that's all open sourced. So all the extensions are open sourced, and they can be reused, they can be upgraded, you can create your own integrations, and that's the answer I can provide right now, because there is, at this point in time, no EBS integration right now.
Okay, cool. Yeah, I like to see that that there's extensions available, because I don't know, I kind of like extensions on the K6 side too. So, but so what are the extensions written in? What language? Is it Go or?
It's up to you. So how we are doing it? You are installing the agent in your system, and this agent is providing an endpoint, and you can use this API, this endpoint, with whatever you would like to. You just need to provide the required data for this connection. So it's like some of the extensions are written in Go. Some of the extensions can be written in Python, whatever. It's up to you. You just need to use an API.
So it's strictly API based. Okay.
Yeah.
Cool.
Okay. That's really cool. So I know when we were talking, Benjamin, we were talking about how we can integrate K6 and SteadyBit, and there are really two ways to do it. The one that you showed us is how to call a K6 script and run it from within the SteadyBit platform. But
Exactly.
the other way is kind of like the opposite. It's how to call SteadyBit within K6.
Exactly. And that's also the preferred way if you really need to generate high load, because this load needs to be generated outside of your system under test, which is a normal way. And also one of our customers is doing it. They have created a very big load test, and they are executing it once. In the first one, without any bad behavior injected by SteadyBit, and in the second one, they are repeating the same load test and inject bad behavior with SteadyBit to see, okay, where's the difference? Where's my system? Where's my breaking point in the system? And where I need to improve.
Nice.
Okay, so if you don't mind, maybe I can show some things on our end.
Yes, please.
Okay. And true to form, the thing with chaos testing that I realized is that when you do it just before you go live, just to check to see if everything's okay, you could actually screw up your application. And so as you can see, I'm facing like crash loop backoffs for some of the pods here. So I can't actually show you that site, but I am using the same demo application that Benjamin was using, but I can show you the script. because I did actually already run it. Now, don't even bother trying to look at my API token because I'm going to be changing it right after this. I wanted to say, like you were talking about, Benjamin, about how extensible SteadyBit is. I, without any help from Benjamin, was able to go through the documentation and figure out how to run a test and also call the SteadyBit API. So I guess kudos on that. I really like your documentation. I had never used SteadyBit before, so that was really awesome. I also didn't get any special account. I'm on the free account from SteadyBit. I'm not entirely sure what the limitations are on that, but I haven't run across them. So I basically, what I did was I deployed this example application in Minikube. So it is local, and I'm hesitant to dig too much into it because I'm using the same machine that I'm using to stream this, which in hindsight was maybe not a great idea. But the first thing that I did after I deployed this application, was to create a K6 script. So this is, I think this is a more comfortable way for me to do it rather than starting from SteadyBit and going to K6. So I have a lot of things here. So I've hidden some things. What you need to know is that I have this function that just represents like normal load. It just goes to the product. It hits an API endpoint for products, and it expects that certain things will be returned. In this case, the information about a quadcopter drone, which caught my attention. And
Normally,
then
it's the
yeah,
product socks which is getting the attention.
which one is it?
Socks. This
Oh, the
colorful.
sock. Well, that's so. Come on, you can have a quadcopter drone, and you'd prefer socks. Okay. So that's what I'm checking for. I'm checking for the response. And the idea is that, like you were saying, Benjamin, if you just run a chaos attack in isolation, then you're not really sure if the environment is already stable. So ideally, I think maybe this part, or I mean, this is a very simplified version, but it is also a simplified demo app. But ideally, I think maybe this part could be executed a little bit before the chaos attacks start, and also maybe verifying responses and stuff, just to make sure everything is up and running before you even change anything. Because if something fails in this part, you're already seeing performance bottlenecks. I think maybe that's a clue to not proceed with more chaos, because you already have something to go on.
Which is a very important part, because to inject more bad behavior or chaos in an unhealthy system, you're not creating new value for you. You need to check first if the system is working as it should, and then you can continue.
Yeah. And then the next step for me was to install the agents, and I installed on Kubernetes using Helm. And let me show you the SteadyBit dashboard. So this is my account, and look, that says there's one agent operating, and this is what it looks like. It's already detecting the namespace of it, the fact that it's a Kubernetes cluster. And so this agent is sitting on my cluster and basically feeding back information to SteadyBit itself. This process was also pretty easy. Now, the way that I did it was I went to experiments and I created the experiments here. Now, because SteadyBit has an API, there's even this interactive thing with Swagger. So there's a lot of things you can do, including creating your own experiments. So one thing that I didn't get to try is actually creating the experiment within the script. That seems very interesting and very chaotic. The way that I chose to do it is to create experiments already, and then to just call these ones. So I just started with 4 of them, and with each one you can go into them and then see the settings. I don't have like a full sequence of things like you did. I just wanted to keep it simple. And actually, this is the experiment that I ran, by the way, that screwed up my local deployments. So maybe I should have tested it with something else. I terminated the fashion pod.
1 second.
Which apparently is a no-no. Yes?
1 second. Can you reopen the experiment, please? Yeah. There's a tiny icon on the right side. It's like a paper with some notes on it. Yes. Click on it, please. And then you can use this code to create an experiment via API. So you can use this UI, drag and drop, and then create it via API.
Yeah, and I believe that you can also do it in JSON, right?
Yeah, exactly. JSON or YAML.
Yeah.
The hard part was to do YAML.
Yeah, so passing it into in as a payload was also something that you can do. I just kind of think, though, I don't know, if I were using this, I think I would prefer not to create the experiment on the fly and instead to have repeatable experiments already that are in the account. So we'd have like a team account and everybody would be able to run specific ones. And that way, we can just make sure that we're running the same thing. We're not changing anything in the payload. Just a little bit more consistency, I guess. And then, so I created the experiments on that. And then on the K6 side, what I did was I created another function. So this is one for stopping the pod. And this is using, so the SteadyBit, so I had to put the domain here for my site, my app, and then the SteadyBit domain and my token, which I will need to rotate right after this. I'm passing the authorization token as a header. And then I'm basically just calling this. So, well, first I check whether experiments are found and to see whether there is a list there of things to choose from. And then I go to this endpoint to execute this ADM1, which is kind of the key for the experiment. So if we go to SteadyBit, that's this one, the terminate fashion pod, for example. And you can also check for response codes. You can, I think in some other places, I also, like this was something that I think is like a good best practice thing, like checking to make sure that the phrase no active agents found does not appear in the body. Seems like good practice when you're running a chaos test. Otherwise, you might just see like everything pass, but it didn't actually run because the agent hadn't been found. So that's something that I figured out. And while I was scripting, I basically just used it like this in a default function, and then I would just comment out whatever I wanted. But I think when you're doing something that's a little bit more like not in the troubleshooting or scripting phase, I think it would be better to have like these test options for it. So let me show you. Here I have two scenarios. One is the API. That's the one that I showed you earlier for getting the product and checking the and verifying whether something is returned, that drone that I want. And I also like this because you can set stages. So this is what I was talking about earlier, how I don't really want the chaos attack to happen at the beginning. I ideally want it to happen after I've already been running this test for a while, because that way I have something to compare it against, like a before or after. So in this one, I'm just using a ramping views executor, and I'm using 3 different stages. So I have the ramp up, the steady state, and ramp down. This whole test takes 20 minutes. And I mean, it's only up to 10 virtual users, so it doesn't really need the ramp up or ramp down, but I just wanted to be able to clearly see it in the graph. And then I have the delete pod scenario. And this is why having test options is so important, because then you can control these scenarios separately. So like what Benjamin was doing earlier in SteadyBit was doing the same thing, basically trying to run different types of tests maybe, or attacks at certain times and trying to schedule them in. This is like the K6 way of doing it and being able to change individually when things run. So for example, in this delete pods attack, I wanted it to start 3 minutes in, that's well into steady state for the test, and after the ramp up as well. And then I had a difference in virtual users. So here I'm running 10, and really with a chaos attack, I wanted it to be iterations based. I didn't want it to keep doing it over and over again. So I just wanted to have it done for like one iteration with one virtual user. But, depending on how chaotic you feel today, you can always ratchet that up and see things burn.
Today's a good day.
And well, yeah, I went a little too far. I don't know. Maybe I just let all that power get to my head, and I ran one experiment too many, and now I have to fix this application.
You were just
which
very
is a problem.
angry today.
Yeah, maybe. I was disappointed because it was just recovering so easily. I mean, that's like waving a red flag in front of a tester's face. It's like, challenge accepted. So the cool thing is that you can, if this would not work, but you can run this whole test, the load part and the attack, just by doing K6 run. But I thought it was going to be cooler if I could actually send it to K6 Cloud. And the way that you do that is just by adding this little flag. So this just means that this is still going to be running locally. It's a local execution, but it's now sending all of those results onto K6 Cloud. Luckily, in preparation for the demo god smiting me, I did actually run this earlier. So let me show you what that looks like.
Yay.
So I
we'll
promise it worked.
Yeah.
Yeah. So this is cool. This was running in real time while that test was running, and you can see this is the ramp up and also starting the start of a steady state. And then you see this blue thing is response time, and it just ratchets up and then just errors from then on. So the application never recovered. This was a delay of traffic attack. So that was cool. Yeah. And there's nice performance insights that say that there's an increased HTTP failure rate, of course. And it's showing when it actually started to happen. It was this URL that stopped responding. And you can also go to other ones. This one was the pod deletion, which worked here, which is why I thought it would be safe to try. So this is what happened. I mean, this is so awesome to see. Like you, Benjamin, I love seeing the red. So it's like, yeah, that's where we need to work. That's where we need to look. So everything was going okay until whoop, high response times, high error rates, and pretty much like while I was watching the site at the time, and it was just unreachable. And then it recovers. So I think, so this is 3:19. Yeah, okay, so about 6 minutes in, it recovers, and from then it actually goes back to the performance as it was at the beginning. So that's kind of good to see as well. So this is still, if you look at the top, it still says it's a local execution. And the reason is that while you can run things on K6 Cloud, obviously, like in this case, this application was not publicly accessible. And so it would have been difficult. K6, you aren't able to just start your own virtual machines or something that have your demo app on K6 Cloud. So this is a way to get around that while still getting the benefits of the analysis. Of course, you can always go into analysis here. And if there's something that you want to look at, you can add new charts to specifically look at whatever you are concerned about. And then so I kind of wanted to take it a step further as well, because we have this thing called the K6 Cloud Grafana app, which I also have here. So this is my free Grafana Cloud account. And I see the same thing. In fact, like it is very similar just with Grafana colors pretty much. And if we go here, we should see the same thing that we did earlier as well. There we go. So I noticed that SteadyBit doesn't technically have an integration with Grafana, but through K6 Cloud, because we have this K6 Cloud app, which comes with all of these dashboards without you having to set it up, it kind of already does. And yes, dark mode is one of the reasons you should use the Grafana Cloud app instead of the K6 Cloud app. For now, we're hoping that does change. So yeah, so you can, if there were thresholds, which honestly, you should have really, you'd see them there. And also some of the checks are here, including the success and fail counts. And the cool thing is that if you're already using Grafana for your application, you could have the results of the test side by side with, your other the other graphs that you would already be using for observability. So it can kind of be like a one-stop shop for it. There were a few things that I didn't get to do. As I said, I only did this yesterday. I did wish that, for example, things like SteadyBit agents found, I think if I were doing this, for real or properly, I would have some kind of setup function in K6 where you check for certain requirements. So one thing I check is, are there SteadyBit agents that are found in the cluster? Are there experiments that we can find using that token? Are there things to run, basically? I even thought that because we have XK6, you could actually do a custom binary of K6, throw in Kubernetes, which I actually started to do. So I did create my own binary with XK6 browser and Kubernetes. The thing with Kubernetes is the Kubernetes extension is that you can maybe look for certain things. So like maybe you can check to see how many pods are returned and what are their names after the test. Maybe you can do that again and say, okay, it was actually this pod that we targeted, and did that recover? How long did it take to recover? What about the other pods? Were they mysteriously affected? Things like that you can really start to build this out. And I also noticed that in the application, it does have these convenient endpoints like the products one, but that initial page is mostly JavaScript. And that's why I thought of running XK6 browser as well. So imagine, like in this section where we have different scenarios, we could have an API testing scenario. We could have the chaos attack that comes partway into the test. We could also be monitoring the front end performance of the browser. What is the browser experience? Because when you're doing these very targeted chaos attacks, it is possible to target some component that maybe will cause your API tests to fail, but maybe your browser tests won't even be affected. That's interesting to know. And the thought of having them, all three of them in the same test and controlling all of these variables separately, I think is super cool. Another thing that, sorry.
It's very important also, not only to check on API, like you mentioned, it's also like your end user. What is in front of your end users under bad conditions? Are there still any fallbacks in your UI? Are there any messages they can consume because service is not reachable or whatever? That's something you need to check as well.
Yeah, and with the XK6 browser, as I said, I started to do it. I should have done it earlier so then I could actually have filled it out. But I got to the point of taking screenshots. Screenshots are super useful, especially when you're trying to determine just the end user experience. And so this was the last one which did work, but I did have a few screenshots that XK6 browser took during an attack, and it showed like, internal server error or something like that. just having those things, these artifacts and different ways to check what happened is just really essential, because it can be difficult to tell or to predict how your application is going to behave.
Mm-hmm.
I also thought, I even started to build out this experiment CSV file. Like you could, right now I was just hard coding it, but really you could have a CSV file with all of the experiments that you want, and then selecting it in a certain way. For example, check to see whether one of the pods has the name fashion, the word fashion in its name. If yes, then run ADM1. If not, then maybe run, then you can get into conditional testing, which is one of the benefits of this imperative approach. So a lot of chaos testing tools make it very declarative, but with the help of K6, you could turn those things into something that is like conditional chaos. I think that's a cool name for it.
I'm glad you mentioned that, though, the different extensions, because at first I was going to say it's kind of cool that you don't, since it is all API based, that you don't actually have to have an extension with a SteadyBit client compiled in or anything like that. But if there's no extensions, then there's no need for me. So I guess it behooves me that you mentioned the x86 Kubernetes, so that way then I'm still gainfully employed. So
yeah, no, your job is safe. I mean, I don't think that the extensions are necessary. I think ideally you would not start with everything thrown in. I
right.
think you should start as small as possible. Is the application functional?
Yep.
Which in my case is no. And then you can build from there.
Something I would like to know, because maybe there's a new feature coming up in my head. I don't know quite. I need to understand more. But you have used SteadyBit in a way, in a time-based way. So you have created an experiment for 20 seconds, 20 minutes, whatever. What if you can use it in a more event-driven way, like event run attack, event stop attack?
Mm-hmm.
It's then more in a controlled way. You can use a K6 load test to start the event of attacking a specific pod until you tell SteadyBit again to stop it. And then you don't have to take care about the synchronization aspects, like keep everything in sync.
Yeah, I think there's a use case for both. I think I'm a tester primarily, so I just think of it in terms of like that time-based approach and being able to see exactly when it happens. I think seeing that on the chart and being able to pinpoint exactly where it's going to be. I mean, if you had different attacks and it always happened there, that would be kind of cool, right? Like how much worse is it if I delete the pod versus stopping it? That kind of thing. But I can definitely see that, especially with the conditional chaos approach that I was talking about, that maybe that would be better for a more event-based attack.
Exactly.
Because you could look at something like Celery or some other queuing system if you want to do it queue-based. So.
Very nice.
Yeah.
Yeah, so I actually really liked SteadyBit. Can you tell us about the limitations of the plans?
So start free is you can use one team inside of SteadyBit. So it's like you have one team with unlimited restrictions. Normally you can use our teams model to say, okay, this team is allowed to do attacks on the host level. This team is allowed to do attacks only on the network layer, only in one specific name of Kubernetes. But in a start free, there's one team. You can use it in any areas. And the second limitation is just the number of agents. So you can install 10 agents in the free model, and that's the limitation. No limits on experiments, on attacks, no limits on all other parts of the product. No.
That's actually pretty awesome. It's a very generous plan. I was wondering because I never ran into limits, and I ran a lot of them. I ran pretty much every experiment before choosing on the ones that I did.
Yeah, normally it's this event when you would like to roll it out to your teams. You would like to reuse experiments. Maybe you would like to share some templates or copy some templates in other areas of your organization. That's the normal trigger event when you would like to get more than one team.
Yeah. No, that's awesome. So we have just only a little bit more time. Is there anything that you'd like to recommend, Benjamin, if people want to get started with SteadyBit or with just resilience testing in general? Where would you tell them to go?
First of all, get started with resilience testing, with chaos testing, because not only happy path testing, please. There's so much you can learn from it, and start small. Start on your local machine with just maybe use kubectl to delete a pod, or to maybe use Pumba as a very nice open source project to do something on a container level. But at your journey, there are some steps you will achieve, or some steps you have to do, which maybe you will pick up a tool like SteadyBit to be more focused on your use case, on your business case.
Okay, awesome. Paul, any last words or questions?
I was just going to say I was disappointed you said kubectl, because everyone knows it's kubectl.
No, I'm with him on this. It's CTL.
I don't know.
I mean, kubectl, where's the second U? It's not there. I'm on the CTL account. Don't worry, Benjamin. All right. Well, thank you for joining us.
Thank you very much for your time and for this great opportunity.
Yeah, look forward to having you on again after some of those features are implemented.
Yes.
Yes, that would be awesome.
Conditional
thank you.
chaos.
Mm-hmm.
Yes.
TM.
I would trademark that.
Okay.
No. Thank you to everybody who stayed with us so far. Have a good weekend, and we will see you next week. Bye.
Bye.
Bye-bye, everyone.